perfect square, we talked about a fraction that's going to happen this year, and we talked about our non-perfect squares. Just simplify those radicals. Don't ever give a decimal, okay? All right, now let's look at our next one here. I've got p squared minus 2p minus 15 equals 0. Now on this one I see I have a p squared, but I also have p. So I cannot use square roots, right? So I have p squared and p, whoops, and there we go, p, so no square roots. I have to use factoring. Okay, so if I go back to my one, I see I have 3 terms here, right? P squared minus 2p minus 15. I have 3 terms. If I look back to my methods of factoring, I can look for a GCF, but then I'm going to use this factor box idea, right? Factor box or bin squared if it happens to be. All right. So if I look back at this, 3 terms, let's say p squared minus 2p minus 15. There's no GCF, right? No GCF on this one. So that means I'm going to do a factor box. Now, some of you might be able to jump straight into those 2 sets of parentheses right away because you can see which factors are going to multiply to give me negative 15 and add to give me negative 2. But for those of you that need a refresher on the factor box, this is what it looks like, right? We make our box. We make sure we have this little nook down in the corner. All right, then my first term, p squared, goes above the first column. My last term, negative 15, goes above the second column because I need to find factors of those. My middle term, negative 2p, is going to go down in the nook because after I find my factors, I need to make sure that once I multiply, they add up to negative 2p. So if I think, okay, what times itself gives me p squared? Well, that's got to be p times p, right? And what multiplies together to give me negative 15? Now this is where you can fill in with all kinds of different numbers, right? But I'm thinking 5 and 3. 5 times 3 would give me 15, but it needs to be negative 15. You can mess around with your negatives a little bit, but put them all in this second column, right? Anytime you need a negative, it needs to go here. Thinking if it's going to add up to negative 2, the 5 has to be negative, right? So now I multiply across. I say p times negative 5 is negative 5p. P times 3 gives me 3p. And does negative 5p plus 3p equal negative 2p? Sure does. So now I have figured out my factor box. So now the only tricky thing about the factor box is to remember that your diagonals are what go into your parentheses. So I have p and positive 3, which is going to be p plus 3 in the parentheses. And then I have p and negative 5, so I will have p minus 5 in my second set of parentheses. And those two can go in either order. P minus 5 times p plus 3, or p plus 3 times p minus 5, that doesn't matter, as long as what's inside each one is correct. Now, some people get thrown off and they say that's the answer, but I'm trying to figure out what p equals, right? So I'm multiplying these two things together and they have to equal 0, which means that if the first one equals 0, the whole thing would, right? 0 times anything gives me 0. So I take that first one, p plus 3, set it equal to 0. Well, that means that p would have to equal negative 3. And then I take my second one. Okay, well, if this anything times 0 equals 0, so if this one equaled 0, it would also work. So I set that one equal to 0, which means p would equal positive 5. So my answers then is p equals negative 3 or 5. Now you could write it like this, right? Or you could write it all in one, but notice here I still have my 2 answers. Okay? So that's fine, you can write it either way, but you do need to show your work. All right, this part right here, this is important work to show. You have to show that work. Don't magically get your answers. Don't magically jump from factor boxes to answers. That's no good, okay? Because I guarantee you at least half the time you're gonna mess up your negatives. So make sure that you write them in the parentheses. You take each one of those parentheses, you make those mini little equations with them, and you just double check your negatives, okay? Because those are the most common places to goof up. All right. I got one more for you here. This is the last one. Just kidding. Second to last one. All right, so we got 3b squared plus 7b equals 0. So again, notice b squared and b, so no square roots, b squared and a b term, no square roots. So we need to factor. Now this time, I only have 2 terms. If I look back at my warm-up here, 2 terms, had it and lost it, there we go. 2 terms, yeah, difference of 2 squares, but I don't think the second one's a perfect square, and I don't think it's a difference. Instead, ooh, GCF. Look at our example here from our GCF. Yeah, and that could be any number of terms. So let's go back and see if we've got a GCF going on in this one. 3b squared plus 7b equals 0. Yeah, notice, right? Not perfect squares, which means no dots, right? Oh my gosh. Ah. No dots. Instead, we need to use GCF. All right, so what do these 2 terms have in common? Well, geez, they both have a b, don't they? So b is my GCF. And then I write my parentheses. Okay, so I say b times what gives me 3b squared? B times 3b would give me 3b squared, right? B times what gives me 7b? B times positive 7. So I have b times 3b plus 7 equals 0. See, now I have my 2 factors again. Just like I had 2 factors back at the factor box, except both of them had parentheses. Now I have 2 factors, except one of them, my first one, doesn't have parentheses. Oops. But that's still a factor. So my first little mini equation says b equals 0. That's an answer. If b was 0, 0 times whatever this gives me, it will still equal 0. So b equals 0 is an answer. Then I take my second factor, set that one equal to 0. 3b plus 7 equals 0. Ooh, now I got to do a little solving. So first I subtract 7. 3b equals negative 7. Then I divide both sides by 3. And I get b equals negative 7 thirds. Is it okay to have a fraction? Yes. Is it okay to have a decimal? No. All right, so make sure that you leave it as a fraction. But notice, there's my 2 answers, b equals 0 or negative 7 thirds. Or you could just leave it like this, box them in, call it good. That's perfectly fine. But see, I still have my 2 answers. Now here's the thing, right? When people see this problem, you know, we talked our way through it right away, but oh my gosh, so many times people want, so you want to square root b, right? Never take the square root of x, or in this case, the square root of b, and never divide by x, or in this case b, right? Never divide by b. Everybody wants to say, okay, well, if I just divide by b, I'll be fine. I won't have that squared anymore. No, you lost an answer if you divide by b. Never, ever take the square root of x or divide by x. Never do it, okay? Use a GCF. That's the method. All right, that one just seems to throw everybody off, so I'm glad we talked through that one. All right, this one really is our last one now. It's 26n squared plus 64n equals 6n squared minus 12. Now, here's the big thing that we haven't really talked about. When we were doing our factoring ones up here, notice this one already equaled 0, this one already equaled 0. You need to make sure your equation equals 0 before you factor. Okay, I see that I have my n squared and my n's. I have another n squared, so I can't use square roots. I'm going to factor, right? But you need to make sure the equation equals 0, but even more than that, we want to say that we need to make sure the equation is in standard form before factoring, okay? So I can't factor just the left side and just the right side. It's not going to pan out. It needs to equal 0 before I can even set up a factor box, okay? Or use a GCF or do anything like that. So standard form is ax squared plus bx plus c equals 0. And the good thing about this is if I get it into standard form, I have to get it into standard form, right? It has to equal 0 before I can factor. And if something happens and the factor box just won't work, then it's in the right form for using your quadratic formula. So the process will even help you out if you can't get it to work. But I promise you 9 times out of 10, factoring will work and it'll be so much easier than doing a quadratic formula. All right, so first thing I need to do is get it equal to 0. I'm going to make sure everything is in the right order along the way. So I'm going to subtract 6n squared, right? I'm going to add 12. Now I notice 12 doesn't have any like terms, so I'm just going to make sure that it goes on the end. 26n squared minus 6n squared is 20n squared. Plus 64n plus 12 equals 0. Watch those negatives, okay? Make sure you're moving things to the other side and doing the opposite operation in order to jump that equal sign, right? Holy cow, now those are huge numbers, and when you have huge numbers like that, you should really be looking for a GCF, and there for sure is a GCF on this one. 20, 64, and 12. Looks like I could get a 4 out of that for sure. Let's see if we can do it. So here I have 4 times 20n squared. 4 times 5n squared would give me 20n squared. 4 times 16n would give me 64n. 4 times 3 would give me 12. All right. Now let's see. I'm going to have to use a factor box on this one. Especially when I have that term in front of the n squared, that's tricky. So I'm going to put the 5n squared here. Now make sure that you're just doing this trinomial, right? Ignore the GCF factor. You could divide both sides by that GCF if you want to, since there's no n in the GCF, but I'll leave it there for now. Positive 3, and it's got to add up to 16n. Okay, let's see. 5n times n gives me 5n squared. Must be 3 times 1. Oh, okay. Now if I multiply across, 5n times 3 gives me 15n. N times 1 gives me 1n. 15n plus 1n gives me 16n. So I got it. Okay. So now I'm going to start over here, and I'm going to get those parentheses. But remember, diagonals, right? Diagonals are our parentheses. So I have 5n plus 1 in my first set of parentheses. And then in my second set, I have n plus 3. All right, and again, if you don't need the factor box, you can go straight from that trinomial to your 2 parentheses and get it right using just your mental math, guess and check. That's fine, but if you're getting stuck, use your factor box, okay? The factor box is not required work to show. The parentheses are absolutely required, okay? All right, now it looks like I have 3 factors this time, and I'm just gonna use the same process, right? I'm gonna set each factor equal to 0, but this first one, when does 4 equal 0? Never. So that one just kind of gets crossed off. You could also think of it as dividing both sides by 4. That would be okay. But I do have this first set of parentheses then, 5n plus 1 equals 0. Subtract 1, I get 5n equals negative 1. I divide by 5. I get n equals negative 1/5. Right? Watch those negatives. That's why we show our work. Here I have n plus 3 equals 0. So I subtract 3 from both sides. I get n equals negative 3. So negative 1/5 and negative 3 are my 2 answers. Again, 2 answers, right? All right, so the big thing from that is if your equation is not in standard form when it starts, get it into standard form. If you've got that n squared and n, right, or x squared and x, or whatever it is, if you're going to have to, if you can't use square roots, you got to get it into standard form. So move everything to one side and then figure out how you're going to factor it. All right, guys, that was a lot to review, but you can do it. You've done it a lot last year, so you've got this. Remember, x squared and no x is square roots. If you have an x squared and an x, factor. Yeah, if you can't get the factoring to work, there is a quadratic formula, but I promise you, you will make less mistakes if you factor it. So just practice your factoring, okay? And never divide by x, or never take the square root of x. Use that GCF, okay? Those are the sneakiest ones. You can do it.